Welcome to the Explainer. Have you ever stopped to think about the secret language your devices are speaking, like right now, to connect with servers all across the globe? Well, today we're going to decode that invisible architecture that makes our entire digital world tick.
You know, a video call to another continent, a message that arrives in a blink, it all feels a little bit like magic, doesn't it? But it's not. It's actually this fascinating system of connections and rules. So let's pull back the curtain and see how it all really works.
So first things first. Before any data can be sent, before a single website can load, two devices have to establish a path between them. It's kind of like picking up the phone and waiting for the person on the other end to answer. You need that line to be open.
And that's what a connection is. It's that dedicated, temporary line for a conversation. This is the absolute fundamental first step for everything you do online.
And right away, you have a choice to make. One you probably make every single day without even thinking about it. Are you going to plug in that Ethernet cable for max performance, or are you going to connect to the Wi-Fi for the freedom to move around?
And there's a really clear trade-off here. A wired Ethernet connection, it's almost always going to be faster, more stable, and definitely more secure. The big weakness, of course, is that you're physically tethered to one spot. Wi-Fi, on the other hand, gives you that incredible freedom and mobility, but that comes at a price, potential slowdowns, and a less secure signal that could, in theory, be intercepted.
So, okay, once that connection is made, how on earth do all these devices from all these different manufacturers running completely different software all understand each other, right? They can't just shout signals into the void. They need a shared rulebook. And that rulebook is what we call a protocol. Think of protocols as the essential grammar of the internet. They define the structure of the conversation, making sure a request from your laptop in London is perfectly understood by a server in Tokyo. Without these rules, it would all just be digital noise. Now, there's a subtle but really important difference here between a protocol and a standard. A protocol tells devices how to format the conversation itself, but a standard, like the Wi-Fi standard, makes sure that everyone's equipment is built to be compatible in the first place, so they can all join that conversation to begin with.
All right, now let's meet some of the most important protocols, the real stars of the show that run our digital lives, the ones you are using literally every single day.
Here's a great way to think about this. Your IP address is like your home's mailing address. It's how things find you on the internet, but it can change if you move to a new network. Your MAC address, though, that's like your device's permanent fingerprint. It's a unique hardware ID that never, ever changes.
And this is the absolute foundation of everything. TCP/IP isn't just a protocol. It is the core set of rules. It is the very engine that powers the entire internet.
They work together as a team, and it's brilliant. TCP acts like a super efficient shipping manager. It carefully breaks your data, let's say it's a photo, into these small numbered packets. Then IP acts like the postal service, slapping the correct destination address on each individual packet to make sure it gets routed correctly across the vastness of the internet.
And then, built on top of that TCP/IP foundation, you've got all these other protocols that handle specific jobs. When you're browsing a website, that's HTTP. When you upload a huge file, that might be FTP. And your email, it relies on SMTP to send messages and POP or IMAP to pull them down to your inbox.
Okay, so we know how devices connect, and we know what language they speak. But with literally billions of conversations happening all at once, how do they keep everything safe and organized?
Well, this is where encryption comes in. It's basically the internet's secret code. It takes your readable data, what we call plain text, like your password or a credit card number, and it uses a key to scramble it into completely unreadable nonsense called ciphertext. This is absolutely essential for keeping your private information safe.
And you see this in action every single day. You know, the S in HTTPS at the beginning of a web address, that stands for secure. That, plus the little padlock icon you see in your browser, is your sign that encryption is active and protecting your data. So the final piece of the puzzle is organization. And to keep all of this from becoming a tangled mess, the protocols are cleverly organized into layers. Each layer has one specific job to do, and it only talks to the layers directly above and below it. It creates this incredibly efficient and manageable system. And the real power of this layer design is flexibility. I mean, because each layer is independent, you can completely upgrade one part, like swapping out old copper for super fast fiber optic cable down at the physical link layer, and you don't have to rebuild the entire system. It's genius.
So let's zoom out and put this all together.
What have we learned about this invisible yet totally vital architecture that underpins our whole online world?
It really comes down to these 4 things. Connections open the line, protocols provide the language, addresses make sure the message gets to the right place, and encryption keeps that conversation private. It's those 4 building blocks that make our seamless, interconnected world possible.
But here's the thing to think about. The internet's rulebook is never finished. As our world fills up with smart homes, self-driving cars, and all sorts of new technologies, we're going to need new rules to govern them. The real question is, what will those rules look like? Thanks for watching The Explainer.